Section 8.2 is our introduction to quadrilaterals, and this is where we look at our properties of parallelograms. Before we go further in our properties, we have to define a parallelogram. And a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So all the shapes we have here, all the quadrilaterals shown, are in fact parallelograms. We may know them as different names, maybe a rhombus, a square, or a rectangle, but they are all parallelograms by their definition of the opposite sides, both pairs, being parallel. So if I have my parallelogram PQRS, I know that PQ is parallel to SR. I know that QR is parallel to PS. So that is what I have when I'm looking at a parallelogram. Where we go from here is we now have some theorems that introduce new properties for parallelograms, but remember, it still comes back to a parallelogram is just a quadrilateral with both pairs of opposite sides being parallel. Okay, so let's start with our properties. These are actually theorems in our book. The number is the one following each theorem, and they all start off the same way if a quadrilateral is a parallelogram. So we've just kind of finished them to condense them. So we're going to label each one as P, Q, R, S. So in our first one, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So let's rephrase that. So now I'm looking at PQRS is a parallelogram. Then, again, opposite sides. PQ is congruent to SR. And PS is congruent to QR. So, opposite sides are the same. If I knew values, I could set these equal, and I could set these equal. And that's really how we'd use that property. Next one, 8.4, is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So, if PQRS is a parallelogram, then now we're going to name the angles. Angle Q is opposite angle S, and angle P is opposite angle R. So those are congruent by our values. Same idea as the previous one. If I know these values, I can set them equal. If I know these values, I can set them equal. Now, we're going to look at some examples later, but remember, we know those opposites are the same, as well as the total would also be 360. We'll get to that one in a little bit. Now, opposite angles congruent goes nice with what the next one is as well, and that is looking at the consecutive angles. So, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So, if we have PQRS is a parallelogram, then consecutive angles are supplementary. Well, how are we going to write that? Well, first of all, we're saying that the angles next to each other would be supplementary. So I could go through and I could list PQ would be supplementary, QR supplementary, RS supplementary, and SP are supplementary. That's a lot though. Let's take what we just said with the opposite angles being congruent and use that to our advantage. Because I know that Q and S are the same. I don't necessarily know what they are, but I know they're the same. I know P and R are the same. Again, I don't necessarily know what value they are, but I know they are the same. So I'm going to call them X's and Y's, because by doing that, I can now say my consecutive angles of X plus Y are supplementary because they add up to be 180. So that way, no matter which two pairs of angles I may look at, they're still going to be supplementary because there's an X and there's a Y. Our final one, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So in this one, if PQRS is a parallelogram, then let's see, how are we going to represent diagonals bisecting each other? I've drawn my diagonals. They intersect at point M. So to say that they bisect each other, that means that QM is congruent to SM, and PM is congruent to RM. So I take in each diagonal, and it breaks it in half. M we can think of as a midpoint to each diagonal. Breaks it in half, I can set those parts equal, and I have that exists. So those are our 5 properties. First one, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Now, before we go further, let's take a step back and just kind of think of what type of problems we may have here. Right? We have some examples for the other ones, but the opposite sides being parallel, what kind of solve for x, find the value type problems could we have? With the opposite sides being parallel, maybe we need to be aware of the fact the slopes of parallel lines are the same. Because maybe we give this shape on a graph or a grid, we have to plot the points, and if we have to show it's parallel, we could check the slopes to find them that way. Really, that's what we could probably expect from that. It really comes back to that just being the definition. Now, the other 4, though, we can kind of narrow in to what type of problem it's really going to be. For example, if opposite sides are congruent, maybe it's one like we have in the top left here, where I know that AB is x plus 4 and DC is 12. If that's the case, x plus 4 equals 12 because those sides are opposite and they're equal. So, x equals 8. For opposite angles are congruent. I know that y and 65 are opposite of each other, so they're equal. So y is 65. But let's go a little bit further on this one because the angles offer a little more opportunity. If y is 65, I know both of those are 65. That means those 2 angles together take up 130 degrees. Now, the total within a quadrilateral, or a parallelogram, is 360 degrees. That means for angles B and D, I have 230 degrees left over. Well, opposite angles are still congruent, so actually B and D would each be 115 degrees. And again, of course, we have y is 65. So just by knowing that opposite angles are congruent, or they're the same value, and the fact that the angles in a quadrilateral, or parallelogram in this case, have a sum of 360, if I know one angle, I can find all of them. And this is something very different than when we looked at triangles. In triangles, even though it only had 3 angles, if we knew one of them, we didn't quite have enough information to find the rest. But now, with a parallelogram, opposite angles are congruent, and with a little help, actually, even though we haven't mentioned it, from our next one, consecutive angles supplementary, we can help solve it. So, on a consecutive angle supplementary, I look at those 2 angles. First off, they are not opposite of each other, so I'm not going to set them equal. Even just kind of taking a general approach to it, they don't look like the same angle. And in a parallelogram, when angles are consecutive to each other, they typically aren't the same. The only case would be if they were 90 degrees. So, consecutive angles are supplementary. So 2x plus 50 equals 180 gives us 2x equals 130, and x being 65. If I wanted to, I could go further and find the rest of the angles here, but we're okay with what we have. What I do want to look at is, notice this problem. If I just take this piece of my parallelogram, I have L, I have M, I'm extending things out. This actually turns into a problem where we have parallel lines cut by a transversal. This goes way back a few chapters, but again, those types of angles there are consecutive interior angles. And if you remember, consecutive interior angles were, of course, supplementary. So in a parallelogram, when we have parallel lines going all around, of course the angles next to each other will also be supplementary. Our last one looks at the diagonals. The key thing for the diagonals bisect each other is honestly get the setup correctly. The diagonal that is bisected needs the parts equal to each other. So 15 equals 5a is how I'm going to set it up because they come from the same diagonal. That point is the midpoint. Those parts are equal, so A is 3. And then I can say B minus 1 equals 9, and B equals 10. Get those set up right, and really for all of these problems, it comes down to the setup. But on this one, pick the right ones that match up. You'll find the right values. Now, why we took this basic of approach? It's taking these theorems, really properties is what we'll refer to them now on, and taking them and knowing how to relate them to a problem. Yes, these are basic examples, and the numbers may get more, and we may have more complicated problems. But if you know how to take those 5 properties we have and able to translate them to the types of problems we have here, you can then carry that over and really apply it to any problem, making sure you get the correct setup. Remember your 5 properties. 5 properties for a parallelogram. Your first one is opposite sides are parallel. Your next one is opposite sides are congruent. Then opposite angles are congruent. Then consecutive angles are supplementary. And last, diagonals bisect each other. You got to remember those 5 and then how you apply them to the problem.